All right, Year 10, just a quick video on algebraic fractions. That's what we're going to be doing this week. We're going to be simplifying algebraic fractions. Here it is, chapter exercise 3E. And I'm going to go through some of these. Some of them are quite difficult, but hopefully if you're having trouble at home, you can watch this and see if it can help you have a go on your own. So I'm going to have a go at question 5 and explain it. Now, remember that when we're doing these algebraic fractions, that we are cancelling. We're finding factors that go into the top that also go into the bottom, and we are cancelling down. Remember, you can do the numbers on your calculator if you need to, and the letters you can do as long as you cancel the right number of pronumerals in top and bottom. So let's have a look at 5a. This is going to be the first one we do. And we've got 6xy on 12x. Now remember, you can do the numbers on your calculator, but a smart student would go, 6 and 12. Well, I know that 6 goes into both of those, and 6 goes into itself once, and 6 goes into 12 twice. And then I look at the pronumerals or the letters and I go, all right, because it's all multiplied on top and all multiplied underneath, I can cancel any letters on top and on bottom. X goes into itself once and X goes into itself once. And that leaves me with a Y on top and a 1, but I don't need to write the 1, and a 2 on the bottom. And I've simplified, remember? Make sure you read the question. I've simplified. So that's what they've asked me to do, and I've done it. Let's have a go at the next one down there. And I'm only doing the first column, E, and I'll have a go at one of the last ones. So here I've got 3. Now don't worry about the parentheses. That's just one big term. 3 times x plus 1 on 3. Now, there's no pronumerals on the bottom, so I only really have to look at the numbers now, and I could do this on my calculator, but I'm smart enough to go, well, 3 goes into itself once, and 3 goes into itself once. Now, I could write this still as a fraction. I could write x plus 1, I don't need to write the 1, over 1, but I don't need to write the over 1 because anything divided by 1 is itself, so I can just get rid of it. And the answer is just x plus 1. So let's have a go at I. What have I got? I've got 4 times x minus 3, and I'm all over x minus 3. And you'll note that I've written the x minus 3 in brackets, even though they don't have it in the bottom, because I want it to look exactly like what's on top. So here we go. I'm going to cancel. There are no numbers on the bottom. Oh, yes, there is. There's a 3. No, it's part of that term in there. So I can't cancel the 4 with anything. But this is a whole term. And x minus 3 goes into itself once, and x minus 3 goes into itself once. And that means I get left with a 4 on top and a 1 on the bottom. But remember, anything divided by 1 is itself, so I can cancel those away or remove those. Let's have a go at the last one, L. And this is 15x minus 4. And I've got 10x minus 4. Again, you can do the 15 and the 10 as numbers on your calculator, but I can do it without a calculator. I know that 5 goes into 15 3 times, and 5 goes into 10 twice. And the x minus 4, it's a whole term, cancels with the x minus 4. Which leaves me with 3 on 2. Now, I could write that as 1.5, but I'm going to leave it as 3 on 2 because I like it as an improper fraction. So that's 5L. Let's move on a bit though. Let's have a look at 6, because we're also going to be doing these questions as well. Now the first thing you need to know here, again we're going to simplify it, but when I look at these expressions, 6a, 4x plus 8 over 4. I can't cancel because I've got a plus. I've got a plus in there. I've got to write it as something multiplied before I cancel. And they gave me a hint in the question. Look, they said by factorising first. Well, that means I need to factorise the expression in the numerator here, because I can't factorise a 4. Well, I can factorise a 4, but I'm going to leave it alone. Now I can take a 4 out of the top, out of the expression on the top, and I'll be left with, well, x there, and take 4 out of that, or divide 4 out of that, and I get 2. And now the top is written as 4 times x plus 2, and I can cancel. 4 goes into itself once, 4 goes into itself once, which gives me x plus 2 on 1. I can write the brackets if I want, but I don't need to. But I don't need the 1 because anything divided by 1 is just itself, so it's just x plus 2. Let's have a look at E. 3x plus 9 on x plus 3. Well, I can't do anything with the numerator, the denominator, x plus 3. I can't factorise anything there. But I'm going to write it in brackets. And at the top, well, I can factorise 3 out of that, and I divide the 3 out of the 3x, I'm left with x. And I take 3 out of the 9 as a division, x plus 3. And I go, great. That means the x plus 3s can cancel because they're a term. And I'm just left with 3 on 1. I'm not even going to write that on 1 anymore because you should know by now I don't need to. Let's have a look at I. And I've got x squared plus 2x all over x. Right, so I can't factorise the denominator, but I can do something with the numerator. And I notice there's no numbers there that I can factorise out, but I can take an x out the front. And that'll leave me with an x plus a 2. And now that's all multiplied on the top. I can now cancel. So I cancel the x. And I'm just left with x plus 2. And again, it's all over 1, but I don't need to. I'm going to now move on to 7. Now 7, I don't have to do any factorising. It just says simplify. And if I look at these, because it's all multiplied, I can cancel, and I can cancel either side. So this is going to be really cool. So I could so if I take 7a, and I got 3 on x times 2x on 9. Now again, you can do all the numbers on your calculator. You can go 3 times 2 on 9 and find out what that will equal. But a good person should be able to cancel. Now, even though they're on different fractions, because they're multiplied, because everything on the top is multiplied and everything on the bottom is multiplied, I can cancel as long as I cancel from the top and the bottom. So I'll do the easy one. I'm going to cancel the x first. The x's go, that's pretty easy. And then I go, all right, well, 3 goes into itself once and 3 goes into 9 3 times. Looks a bit messy, but it's not. So I got 1 times 2 on the top, well, that's 2. And I got 1 times 3 on the bottom. Oh, 1? Yes, because when I cancel that x, there's a 1 there. And that gives me 2/3. Let's have a go at D. I'm just doing the first column. I've got 2x squared on 5 times 25 on 6x. And because it's all multiplied, everything on the top is multiplied, everything on the bottom is multiplied, I can cancel. Remember, you can do the numbers on your calculator. You can do 2 on 5 times 25 on 6, and your calculator will give you the answer. But you should be sitting there going, I'm too good for that. I'm going to cancel 5 goes into itself once, and 5 goes into 25 5 times. 2 goes into itself once, and 2 goes into 6 3 times. So my numbers will be 5 on 3. You could have done that on your calculator. Let's look at the pronumerals. Now remember, x squared is xx, so I can cancel that x with one of those, which just leaves me with an x on top. So my answer is 5x on 3. Okay, so now we go to G. Now they're getting a little bit harder. If I have a look at G, I'm going to write x plus 3 in brackets. Remember that the vinculum, that's the thing between the numerator and the denominator, groups whatever's on the bottom from whatever's on the top. So I can write it with parentheses. And then I've got a 4, and then I've got an x plus 3. It makes it easy once you see it like that, because then you can go, oh, great, that's everything on the top's multiplied, everything on the bottom's multiplied. I can cancel the x plus 3's. The numbers, again, you could have done on your calculator. Nothing cancels, though, and I just get 4 on 9. Righto. Let's have a go at J. J, now they've put the parentheses in here because they've put a 4 in front of it. I've got 4x minus 2 all over 7 times 14 on 5 outside of x minus 2. Now, again, you can do the numbers on your calculator. But first I'm going to get rid of that x minus 2. So that cancels. X minus 2 goes into itself once, and x minus 2 goes into itself once. Now this is going to be a bit tricky. I know 7 goes into itself once, and 7 goes into 14 2 times. Well, nothing goes into 5 that goes into 2 or goes into 4 or goes into 2 times 4. So I'm done. So on the top I've got 4 times 2, which is 8. On the bottom I've got 1 times 5, which is 5. And that's all that's left. I will have a go at the last one, and I'll finish with that, and then you can go and have a practice at them. And I've got 4 outside of 2x plus 1 all over 3x times 9x over 2x plus 1. And I'm going to write that in parentheses so that we realise that everything on the top is multiplied by, everything on the top is multiplied and everything on the bottom is multiplied. Let's get rid of the big thing, 2x minus 1, 2x plus 1. It goes. Let's also get rid of the x. They can cancel out. X goes into itself once because it's all multiplied. And that only leaves me with the numbers. Now you can do the numbers on the calculator. 4 on 3 times 9 on 1. Remember, this is 9 on 1. But I know that 3 goes into itself once, and 3 goes into 9 3 times. Now I multiply out the top, and I get 12. And on the bottom, I get 1 times 1. Well, that's 1. But we all know that anything divided by 1 is itself, and I don't need that there. So the answer should just be 12, and it is. All right, good luck. See if you can do a couple. Remember, the only way to get good at these is to practice.